Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about the notes for similar figures, part 2. And the objectives here are to identify corresponding parts of similar figures, to understand that the corresponding angles of similar figures are congruent, and to determine if a pair of figures are similar based on their side lengths. So first of all, we have to answer the question of what are corresponding parts of similar figures. So here we're given the fact that we know that these two polygons are going to be similar. So you have this one and this one. These two are similar polygons. So corresponding parts really are just simply the sides or angles that are in the same position in the two figures. So here we can say that angle A and angle E are in the same position. So we can say angle A corresponds to angle E. We can also say that angle C corresponds to angle G, so we can say angle C corresponds to angle G. And so those are like the types of angles you would use. You can also use this with side lengths. So side lengths here, if we want to say which side lengths are corresponding, we could say side AB, so segment AB, corresponds with segment EF. EF. Or we could even say segment BC, so segment BC corresponds to segment FG. And here, there are others of course, but what's important to notice here is that no matter where we put these polygons, those sides and those angles are going to be corresponding to each other. So, for example, once I erase here, if I were to rotate this figure here, and let's say I put it like that, the angle here, E, would still be corresponding angle with angle A. Just because that the figure is flipped doesn't mean that those aren't corresponding. Angle E and A are still corresponding, and then their parts are also still corresponding. So EF is still corresponding to AB because they're in the same position in the figure. So let's look at example 1. Example 1, it says that triangle TRQ is similar to XWY. And the way we know that they're similar is because of this symbol here. That tilde, or that squiggly, tells us that those two triangles are going to be similar. Now, it says identify the corresponding sides. So corresponding sides in this case you could say are TR corresponds with XW. That would be one pair. And then you could say that TQ, so side TQ, corresponds with side XW, or XY. And then, of course, the last side will be corresponding. As far as angles are concerned, we could say that angle T and angle X are corresponding angles. So we'd write that like this. And then we could say that angle R and angle W are also corresponding angles. Now, if it's hard for you to visualize what is going on, which are the corresponding parts because of the way the figure is drawn, my suggestion to you would be this: to make sure that you are, number one, looking at the way that the two triangles are named. So the naming of the triangles has a lot to do with what parts are similar. So as you can see, T is matched up with X in the name, and so those are going to be corresponding parts. R is matched up with W, and those are going to be corresponding parts. And then Q is matched up with Y. Those are also corresponding parts. Another strategy you could employ would be to visually in your mind turn the figure so that it's facing the same direction as the other one in the diagram. And so here we can see very easily that now that T and X are corresponding, Q and Y are corresponding, and then this is W, not M. W and R are corresponding. So, we've talked about identifying the corresponding sides and the angles. Now it asks for what is the scale factor from TRQ to XWY. So basically, what is the scale factor from the smaller triangle to the bigger triangle? So we need some side lengths to go with these triangles, and so the red lengths are, and we can see that triangle TRQ here, this one, is going to be smaller than triangle XY or XWY. So what we need to find is what was the scale factor used to increase the second triangle. And so what we look at was you look at the corresponding parts and see what the factor of increase was. So we know that TQ is a corresponding part with the 25 here. So TQ corresponds with 25. And if you want to know what that ratio was, you could say 25 to 15, which you can then reduce to 1 2/3. And that's how you would find the scale factor from the smaller one to the bigger one. I wrote 2/5, I'm sorry. It's 1 2/3. So the scale factor will be 1 2/3 from the smaller triangle to the bigger triangle. You can also do it the other way too. You could say 18, which is the biggest side here, to 30, which is the biggest side of this triangle. So the ratio of 30 to 18 is also 1 2/3. And then lastly, you could say that the smallest side to the smallest side here, 20, that ratio is also 1 2/3. So 20 to 12 is a ratio of 1 2/3. So the scale factor here is 1 2/3. Then under Objective 2, it says, what is the relationship between the corresponding angles of triangle TRQ and triangle XWY? Well, the relationship between the corresponding angles is that they're congruent. We know that if angle T is corresponding with angle W, I'm sorry, not angle W, with angle X. Angle T and X are corresponding. We know that angle T is congruent to angle X. We also know since Q corresponds with Y, we can say that angle Q is equal to angle Y. So that's true for any similar figure. So underneath there it says the interior angles of any similar figures are congruent. All right, now let's look at example 2, and it gives us two triangles that look like this, and we're told that triangle ABC and triangle NLK are similar. We know that they're similar by the small little tilde sign, or squiggly, however you want to say it. And so we need to know what are the corresponding sides of this polygon, or these triangles. So again, we could use the name to find out that A is going to correspond to N, and B is going to correspond to L, and C to K. Or we can visually determine that when we flip this, when we rotate it around, we're going to get a figure that looks like this, and those are in the same position. So now I can say that A matches up with N, I can say that K matches up with C, and B with L. So the corresponding sides then would be CA corresponds to KN, and then CB corresponds to KL. Then it asks us which angles are going to be congruent in this figure. Well, the congruent angles are going to be the same as the similar angles, or the corresponding angles. And so we can say that angle C and angle K are congruent. So angle C is congruent to angle K. And we can say angle N and angle A are also congruent. So A is equal to N. And then, of course, B is congruent to L in this case. Then on the back side, for the third objective, it says we need to determine whether these two figures are going to be similar or not. And then we need to find the scale factor from the smaller figure to the bigger figure. And here, to determine whether they're going to be similar or not, we need to find the scale factor for each of the corresponding sides. So 3 to 15 would be a ratio of 15 to 3, which is 5. So that scale factor is going to be 5. And then the corresponding parts 7 and 35, that'd be a ratio of 35 to 7, which is also 5. So we can say that, yes, these are similar figures because their two ratios from the smaller one to the bigger one are both 5. So the scale factor here from the smaller figure to the bigger figure would be a scale factor of 5. Then on the second example, we have two triangles that may or may not be similar. And we have to match up their corresponding parts so that we see if they're congruent or not. Or, I'm sorry, similar or not. So the biggest side of this triangle would be 12. Therefore, we match that up with the 13 here. So we could say the ratio of 13 to 12. And then we match up the 7, the smallest side of this triangle, with the smallest side of this triangle. So 8 to 7. And then the medium side to the medium side, which is going to be 10 to I'm sorry. So that last side would be a ratio of 10 to 9. And then if we found those ratio, we would say that the 10 to the 9 is going to give us a ratio of 1.1. And then the 8 to 7 ratio is going to give us a 1.14 here. And then the 13 to 12 is going to give us a 1.008. And we can see that those three ratios are not the same. They're all different. So these are not going to be similar figures. Another way you might be able to determine if these are similar figures or not is to literally visually turn the one triangle so that it's corresponding, it's matching up with the other one. And we can see here that, hey, we notice something significant here, that the 12 is the biggest side over here, but the 13 is the biggest side over here, and those aren't the corresponding parts. Those aren't even the same parts of the triangles. And so that's another reason we can say they're not similar. One common mistake that's made by students in this case is where they have this triangle. Oh. They have this triangle, and they look and they say, oh, well, each of the sides has increased by 1. So 9 plus 1 is 10. 12 plus 1 is 13, and 7 plus 1 is 8. And they say, oh, well, that makes them all the same, congruent, or similar. But that's not the case. The scale factor is never adding 1 or adding a number. It's always multiplying by a number. So that would be a false statement there. Let's look at the third example, and we can see that we're going to need to write some ratios. So the ratio for the side HG would be 14.4. And then that same side over here, a corresponding part would be 8. And then this side here would be 21.6 over the 12 equals the 9 over 5. And so when you divide all three of these and get the ratios, you're going to get 1.8 for all of them. Will be 1.8. So that means that all of them are the same ratio. Therefore, these two triangles are similar. And if you're having trouble visualizing which parts are corresponding to each other, visually you can turn, or use your paper and turn which parts go with which. So here, if we're going to say that the two triangles are similar, we need to say that triangle HGL is similar to triangle JKF. And it's important how you write it because the corresponding parts need to match up with the other triangle. So notice how H matches up with J because those are corresponding parts in the figure. We forgot to actually do that for this one here, but we can do it real quick. In that first one we looked at, we would say X, Y, W, Z is similar to J, K, L, M. And again, those corresponding parts have to match up in the way you're drawing it. And so the last figure we can look at tonight is we need to write the ratios for the corresponding parts to see if these are similar. So we'd say here 4 to 10, and we would say then 6 to 15, 6 to 15, and then 5 to 13. So 5 to 13. And when you do those calculations, when you divide each of those, you're going to find that they are not all the same. So these are not similar polygons. So that concludes our lesson for this evening, and come tomorrow with questions in class.